In this section, we're going to look at how to solve a quadratic equation by completing the square. So we've already learned how to solve quadratics by factoring. And as I mentioned in the beginning, not all quadratics factor. If a quadratic factors, great, we know how to solve it. But not everything will factor. Completing the square, however, will always work, and we'll see as you go through not just this math course, but your following math courses. If you go on to take calculus, completing the square is a technique that we can use to transform what an expression or a function looks like. So it's really a valuable skill to have. We're going to begin with some simple examples. So let's say I wanted to solve the equation x squared minus 7 equals 0. Your instinct might be, well, what if I just get the x squared by itself? All right, we could add 7 to both sides. And then we have x squared equals 7. And if I know what x squared is equal to, then I just need to take the square root to get x. Now, when we are the ones who are imposing the radical, if we're putting the radical was not already in the equation, but we're putting it in, we have to consider both the positive and negative square root. So that means that x is equal to positive or negative square root of 7, and those are our two solutions to this quadratic equation. In part B, we have a similar type of equation. In fact, when you look at this, your first idea might be, well, maybe I should FOIL out that x minus 3 squared, but I'm going to discourage you from doing that. In fact, the way it's written right now, it's really going to be super convenient to kind of approach it the way we did the one in part A. So I know what the square of x minus 3 is. Let's go ahead and just take the square root to begin with. So again, I need to consider both the positive and negative roots of 16. And on the left side, when we take the square root of a square, right, we just get rid of the square. So x minus 3 is equal to plus or minus 4. And to solve for x, we're going to add 3 to both sides. So here's what that gives us. That gives us that x is 3 plus or minus 4, which means it's either 3 plus 4, which is 7, or 3 minus 4, which is negative 1. And those are our two solutions to that equation. So the square root method can still work even if it's not just x squared equals, right? It can work if I have x, minus 3 or x plus 5 squared equals something. Taking the square root, any scenario where taking the square root allows us to kind of isolate that x term. And so what we're going to work on is being able to transform a quadratic equation into one where we can use this square root method. And this technique to transform it into an equation where we're ready to take the square root, this process is called completing the square. So here's how completing the square works. First of all, we want to make sure that the constant term is by itself on the other side of the equation, so that I have the x squared term and the x term on the left and the constant term on the right. Then, if needed, if the coefficient on x squared isn't 1, if it's something other than 1, you divide by that coefficient so that you have an equation that looks like this. X squared plus something times x equals some other number. And then this part here is really where we are completing the square. Add the square of half the coefficient of x to both sides. I'm going to show you what I mean by that. But basically, in step 3 here, what we're doing is just being clever about what we want to add to both sides. We know we're allowed to add the same thing to both sides of an equation. We're going to be clever about what we choose, because what we choose is going to make it so that the stuff that's on the left is a perfect square, and then we'll be able to factor it. And then we can solve by taking roots. So let's begin here. We'll note that the x squared coefficient is already 1, so I don't have to divide by anything, but I'm going to get that 5 on the other side. I'll subtract 5. Then I've got x squared plus 6x. Now I'm going to leave some space. I'm leaving some space for the magic. So x squared plus 6 is equal to negative 5. Now, this is where the magic happens. I'm going to be clever about what I choose to add to both sides. I'm allowed to add anything I want to both sides. I can add 7 to both sides. I could have negative 13 to both sides. But what I'm going to do is I'm going to look at this coefficient on x here, which is 6. I'm going to cut it in half to get 3, and then I'm going to square it. Now, so 3 squared is 9, but I'm actually going to write it as plus 3 squared, because that's going to help me in my next step. Now the stuff on the left side here, this is a perfect square. Like, you can unfoil that, and it will be 2 of the same factor. So the way it always is going to work out is, first of all, it's a perfect square, and this is what a perfect square looks like. You take the x and you bring it down. You take the 3, which is a positive 3, and you bring it down, so we get x plus 3. And you could check, if you FOIL out x plus 3 times x plus 3, you will get x squared plus 6x plus 9. On the right side, we have some arithmetic to do. Negative 5 plus 9 is 4. And we have x plus 3 squared is equal to 4. And now this is something where we're ready to take the square root. So let's go ahead and take the square root on both sides. Need a plus or minus on the right side. And we have x plus 3 is equal to plus or minus 2. Now, in the example before, I kind of jumped straight into subtracting 3 from both sides, which you can still do, but sometimes it's nice to break it out to 2 equations just to help us see what we're going to get. Like, basically, this gives us 2 equations. This tells us that x plus 3 is equal to 2, or x plus 3 is equal to negative 2, right? And then we just have these 2 different linear equations. And subtracting 3 from both sides in both of these equations will get us both of the solutions. So we've got x equals negative 1 and x equals negative 5. Okay, let's do another one. We're going to solve this equation by completing the square. I'm going to get the 17 by itself on the other side, so I'm going to subtract 17. (2x squared minus 16x equals negative 17. Now this time notice that the coefficient on x squared is not 1, it's 2. So in order to fix that, I'm going to divide both sides of the equation, or divide all terms by 2. So now I've got x squared minus 8x, I'm leaving some space for the magic, equals negative 17 halves. Okay, now this is where we're going to complete the square. So I'm going to add the same thing to both sides. And what I'm going to add is I'm going to take this coefficient on x, which is negative 8, I'm going to cut it in half, and I'm going to square it. And that's what I add to both sides. When you look at this, you might think, well, if I square negative 4, that's the same as squaring 4, so why don't I just say plus 4 squared? And you could certainly write it that way. I like to make sure I include the sign because it helps me remember, kind of fill in this next step correctly. So this is a perfect square, and what goes in here is the x, and then the minus 4. So that's why I include the sign. It's just a little reminder that I grab the correct sign in the middle. And you can check if you FOIL out, or if you multiply out x minus 4 times x minus 4, you will get x squared minus 8x plus 16. Over on the right side, we need to do a little arithmetic. Let's see, 16 over 1, so I'm going to get a common denominator. That's 32 minus 17 is 15. 15 over 2, that's x minus 4 squared. So now I know what the square of x minus 4 is. I am ready to take the square root. So let's take the square root on both sides. And of course we'll need a plus or minus over here. So you might have noticed that 15/2 is not a perfect square, and that's okay. When we get to this point where we're taking the square root and what we have on the other side is not a perfect square, what that means is that the quadratic equation that we started with would not have been solvable by factoring. So here is our first quadratic equation that we're solving, where we're actually seeing something that we're solving a new quadratic equation that we didn't have the tools to do before, because factoring wouldn't work. What we have now is the x minus 4 is plus or minus. Now, I've got the square root of 15/2. It's not really conventional to put fractions inside a radical, so I'm going to split it up over division and then rationalize the denominator by multiplying the top and the bottom by the square root of 2. So x minus 4 is plus or minus the square root of 30 over 2. And then if we add 4 to both sides, we get x is equal to 4 plus or minus the square root of 30 over 2. And we can leave it like that. Sometimes people want to express it as a single fraction. So if you do that, then we get a common denominator of 2. And then we'd have 8 plus or minus the square root of 30 all divided by 2. And either is fine. This is getting the solution and writing it in an exact form with radicals. Of course, depending on where you encounter these, it might make more sense to get an approximation, and with decimals. So it really just kind of depends on what form it's asked in. If the problem is given without any context, as we encounter it here, I usually default to writing it as an exact form. If no instructions are given, you could choose to get an approximate form.